Blue, the rarest color in the natural world. We see it in the sky, we see it in the ocean. But here, the mind bender. When it comes to flowers, nature almost never makes true blue pigment. That brilliant blue rose, it's not naturally blue. The iconic blue orchid in your local grocery store, that's a dye job. Today, we're going to dive deep into why true blue flowers are so incredibly rare, how some plants fake it, and how humans have tried and failed for centuries to create them. And along the way, we'll discover what this says about evolution, color perception, and even our brains. Let's start with a deceptively simple question. What is blue? Scientifically, blue is light with wavelengths around 495 nanometers. But when we say true blue pigment, we mean a molecule that absorbs every other wavelength except blue and reflects blue light to our eyes. Here's the problem. In plants, the pigments that create colors, called anthocyanins, are great at making reds, purples, even almost black hues, but pure blue, that's a biochemical nightmare. The pigment needs to be arranged in a way that reflects only that narrow blue range, and that's tricky. Instead, plants often cheat. They modify purple pigments with pH changes, mix them with metals like aluminum, or use microscopic structures in their petals to bend light, an optical illusion rather than a chemical reality. So, if blue is so hard to make, how do some flowers pull it off? Meet the Himalayan blue poppy, Meconopsis buttonaciphala. This high-altitude beauty uses a rare combination of pigment chemistry and petal structure to create that sky blue appearance. Then there's the hydrangea, famous for its chameleon-like blooms. In acidic soil, it's pink, but in soil rich in aluminum and with a lower pH, it turns blue. That's because aluminum ions bind to anthocyanins, shifting the reflected light. Even then, the result is usually a blue-violet, not a pure spectral blue. In fact, most blue flowers you see in the wild aren't actually reflecting only blue light. They're mixing purples and cyans in ways our brains interpret as blue. Why evolution rarely picks blue? Here, where it gets fascinating. Even if plants could make blue pigments more easily, would they bother? Flower colors evolved primarily to attract pollinators. Bees, for example, actually love blue. They can even see into the ultraviolet range, picking up patterns we can't see. But many blue-looking flowers to us are just UV patterns mixed with violet pigment. For plants, making yellow or white pigments is far cheaper in energy terms than engineering a complex blue pigment. In evolutionary terms, if a plant can get a bee's attention with something simple, why go through the biochemical gymnastics to make true blue? It's a cost-benefit equation, and for most flowers, blue just isn't worth the price. But humans, we're obsessed with blue. In ancient Egypt, blue was a sacred color, linked to the heavens. In medieval Europe, blue dye from the woad plant was so rare it was worth more than gold. So it's no surprise that gardeners, breeders, and scientists have been chasing the dream of the true blue rose for centuries. In the 19th century, Victorian plant hunters risked their lives scouring the Himalayas for blue poppies. Fast forward to the 21st century. In 2004, Japanese researchers used genetic engineering to insert a dulfanudun gene into roses, creating what they called a blue rose. The catch, under natural light it looked lavender. The dream continues. If chemistry can't make true blue, sometimes physics steps in. Some flowers achieve a blue appearance through structural coloration, tiny microscopic ridges and layers on the petal surface that scatter light in such a way that only blue wavelengths bounce back. This is the same trick used by peacock feathers, morpho butterflies, and even some berries. The result can be stunning, sometimes even more vivid than pigment-based colors, but it's fragile. Change the angle of the light, and the color can shift or vanish entirely. It's like nature's hologram, beautiful but elusive. Why true blue is still elusive? Despite centuries of plant breeding and decades of genetic engineering, the challenge remains. producing a stable, true blue pigment in flowers. Why? Because plant pigment production isn't just about making the molecule. It's about maintaining it in a living cell, in varying soil conditions, in changing sunlight. Pigments can shift color depending on acidity, temperature, even the presence of certain ions in the cell sap. And the more complex the pigment, the more unstable it becomes. In other words, the laws of chemistry are stacked against the blue rose. Part of why we're so drawn to blue flowers is psychological. Blue is often associated with calm, trust, and peace. Some studies suggest blue environments can even lower heart rate and reduce anxiety. And because true blue is so rare in nature, it feels special, almost magical, when we see it. There's a poetic irony here. Maybe part of the reason we want blue flowers so badly is precisely because nature makes them so hard to find. So next time you see a blue hydrangea, a Himalayan poppy, or even a dyed blue orchid at your local supermarket, remember the science, the history, and the centuries of human longing behind that color. Nature has no obligation to give us what we want, but when it does, even if only in fleeting illusions, it's unforgettable. And maybe that's the real beauty of blue flowers. They're not just a color. They're a challenge, a mystery, and a reminder that some of the most beautiful things in life are rare for a reason.